Okay, we're going to now do Chapter 11 review on page 736. I'm going to start with number 23 here. They're going to ask us to figure out the volume of this hexagonal pyramid. And there's a lot of things missing here. The basic formula, of course, for a volume of a pyramid is a 1/3, or divided by 3, the base area times the height. Now the base area, of course, is we got to figure out the area of the hexagon, which we don't have, and we need to figure out the height, which we don't have. So we need to do two parts first, and this will be a kind of involved problem here. First thing I'm going to do is try to figure out the height. They give us a radius of the hexagon going to the corner, and they give us a lateral edge of this triangle. What we need is this height coming down the middle there. And if you look carefully there, I'm hoping you can see that there is a right triangle, where 7 is the hypotenuse, 3 is a leg, and the height, I'll let that be x, is what we're looking for. And of course we would go x squared plus 3 squared is equal to 7 squared. And saving us time here, this is going to be the square root of 40, which is approximately 6.32. All right, so that would go right here for the height. That's all fine and dandy, but now we got to figure out the base area. Of course, that is a hexagon. The only thing they give us is the radius of 3. The area of a hexagon, of course, it's a regular figure, so it's 1/2 apothem times perimeter. We don't have the perimeter, we don't have the apothem, so we're going to need to figure out both. We're going to need to figure out, we're going to first draw this apothem here. We're going to figure out that A apothem, and then we're also going to figure out this portion here, x, which will help figure out a side length, which will help figure out the perimeter. What we do have is a simple triangle here, where this is x, this is 3, and then the apothem makes 90 degrees. We're going to need some angles. Looking at the center of this hexagon divided by 6, because I'm drawing 6 of these radiuses. This is 60 degrees. So each one of these turns here, these openings is 60, 60, 60 all the way around, and now the 60 gets turned into a 30 degrees, and this is also 60 degrees down here. We're going to use trig to help figure out the apothem and then x. So we're going to do 2 trig. Let's solve for x first. Let's go with, stand at the 30 degrees. I'll go opposite over hypotenuse. We're going to say sine of 30 degrees is opposite x over hypotenuse 3. This happens to be 0.5, and it happens to turn out x is 1.5. And so if I go 1.5 plus 1.5, that is 3. Again, how do you get the 3? That's 1.5 plus 1.5. And that's 3. So we can easily figure out the perimeter by adding up all the 3's. We also need this apothem here. Let's stand at the 60 degrees, opposite over hypotenuse. Let's go sine of 60 degrees, apothem, opposite over hypotenuse 3. Sine of 60 turns into an ugly number, 0.866, and then I'm going to multiply that by 3, 2.598. Basically 2.6 is the apothem. Throw all of this into this equation here. The area, the base area of the three-dimensional object, or the area of this hexagon, is 1/2 apothem, 2.598, times the perimeter. Each side is 3. There's 6 sides, so 6 times 3. The area of the hexagon going to the calculator is about 23.4. So that's the base area. That 23.4 comes right here. We go 1/3 because it's a pyramid. Base area is 23.4. We calculated the height using the Pythagorean theorem. This is 6.324. Throwing all of that in the calculator, boom, 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 saving time, 49.3 inches cubed. Now this is a pretty involved problem, but if you can handle this, figuring out the base area, Pythagorean theorem, trig twice, throw it into the volume equation, you pretty much understand everything in chapter 11. All right, I'm going to look at number 24 here. This is the greenhouse problem. We're going to figure out the volume of this greenhouse. It's basically a prison here. So we just got to figure out the volume. You figure out the base area and multiply it by the height. Now the base area is going to be the hard part. You've got to figure out this, consider that the base, kind of like this front side of the house. And then this front to back would be considered the height. So the height is no problem. That's 35. The base area, though, that's what we got to calculate. Okay. So basically, we are down to this guy here. We got to figure out what is the area of this kind of front. Now this is 10. This is 10 here because it's the same as the back. Need to break this into a triangle and a rectangle. With the triangle, we know a triangle is 1/2 base times height. We need to figure out the height. We need to figure out this h right here. This is an isosceles triangle, so it splits it into a 7 by 7 here. And we're going to need to do a little, I'll put an x there for the height. We're going to need to do x squared plus 7 squared is equal to 10 squared, just focusing on one of these right triangles. Saving us time here. This is the square root of 51, which is about 7.14. So the area of this triangle is 1/2 base, which is 14, times height, 7.14. This thing, going to the calculator, is basically 50. So the area of this triangle part here is 50. This area of the rectangle is pretty easy. This is simply base 14 times height of 8. That is 112. So the area of the entire kind of house shape is 50 plus 112, 162. So this entire thing here is 162. That's the base area. And then we multiply it by the front to back height of 35. 35, because if it's 162 here, there's 35 of these slices in here. And of course, I'm not going to draw all 35, but that would be the volume. And this turns into 5,670 cubic feet should be the volume of the entire greenhouse.